Today we are on lesson number 8. So please follow my GitHub link and you can click on lesson number 8. And then there is, I'm going to share my screen. It's sharing. Can you see my screen?
Yes, we can.
Is it the lesson number 8 or something else?
Lesson 8. Yeah.
Okay. Because it doesn't have like a box. Okay, so coming back from Ms. Radha's concern, okay, I think you need to be a child all over again. Don't take it too seriously that you need to follow lesson 1 and then lesson 2 and then lesson 3. It's okay. It's completely okay to jump into lesson 8 because it's a playground. You know, it's a play. It's not a test. It's not like, you know, you need to know lesson 1 and 2 in order for you to do lesson 8. It doesn't work like that, because each lesson is independent of its own. If you just looked at the code in front of you, right? If you see, it all begins the same way. It doesn't matter whether it's lesson 1 or lesson 2 or lesson 8 or lesson, you know, whatever. So you just need to be a lot more open about it. It's like an open university. You know, you come in, you learn lesson 8, and then if you don't understand, then you go back and you learn lesson 1. But it's not a sequential thing. It's just that I'm just trying to make it more and more exciting and more interesting as we go. So that is what I mean by the specials that are coming for the next 4 classes, where I will be trying to show you how to do it on your desktop rather than having to depend on Google Colab. All right. Some of you may want it, some of you may not want it. It's okay. But the idea is that now you can actually run applications on your desktop. And then we're going to cover some very complex projects like machine learning. We're going to do self-driving car and all those things. It will take a bit more time for me to explain. All right. So the idea is, let's say you're given this toy. Okay. When you're given this toy, what do? You press every button. You try to turn it any which way and see how it behaves. Realistically, that's what life is all about. You know, today, if you ask a scientist, why does petrol burn? I always give this example because the chemical construct of petrol, which is either butane or methane, especially butane, has got the same chemical construct as benzene. Benzene is an oil. It doesn't burn. The only reason why we know petrol burns is because of practical application. That means we lit a fire and threw it on petrol, it caught fire. But when we lit a match and threw it on benzene, it doesn't burn. So the idea here is we just take it for the way it behaves. If I put it in a certain situation, it behaves certain way. So therefore, I assume that that's how it's going to behave, and I take advantage of it. I build a car around it. I put petrol in it, and the car runs. If I put benzene inside the car will fail. So the idea here is practice. All right. We just want to see how it behaves. So we are like an experimenter. We are a researcher. And we just try it, and then we record and I watch my 4-year-old nephew, 5-year-old nephew play with the phone. He is teaching me how to use YouTube. I didn't know YouTube had so many functions on its screen that you can go stop and record and playback and all those things that he was like, because he did not have any inhibitions. He just pressed it, and if it worked, it worked. If it didn't work, he moved on. So we need to have that sort of an attitude towards technology, because it's built for idiots. I'm sorry, but this is the truth. All right. So have no inhibitions is what I'm saying, because it is not representative of the technology that we are working with. So try to look at what I am trying to achieve, not how I am doing it, because what I'm doing right now is all over the web. You know, there's so much of content out there, and I'm not trying to compete with them. You know, I'm not trying to compete with them, and I'm just trying to be able to give you this personal experience. That means if you have a question, you can ask, because most of the content out there is just videos, right? You have recorded videos. So if you're just going to sit down and listen, then you just might as well go to the recorded video, and which the whole internet, if you just type Python programming tutorial, hundreds and thousands of videos will come up. All right. So the only difference or the experience that you're getting is this 2 hours, which is going to be 3 hours from next week onward. So this 2 hours is when you can actually ask, hey, I don't know this and I don't know that. And the idea is to be a fool for a minute and to be wise forever, right? It's okay to be called a fool for just a minute, because after that, you know, right? So the idea is to understand that the whole value of this class is pinned on the fact that there is someone who's actually ready to respond to your questions. All right. So this is what I think that students need in terms of trying to understand something that they don't understand. All right. And in the learning process, okay, there's something you have to be very comfortable with, which is called chaos. When you are learning something new, it will all be chaotic. It will be all chaotic, and you need to be calm and composed and glide through this chaos. You will eventually come. It's like how you jump into a pool of water. You know, you feel like you're drowning, but if you're just calm and composed and you hold your breath, you will slowly begin to float. That is the whole idea of chaos, how you manage chaos. And that is the whole idea of learning, right? So it is obvious, it's all chaotic. You know, there's a lot of input, but when it comes to output, there's very little that you can do, right? So you just need to be patient and go with the flow, be a real kid about it. And I think it will make the whole experience more fun, because at the end of the day, it's not an exam. It's not a mark of your intelligence. Let me tell you, there is no intelligence involved here. You just have to follow. If you see this line right here, just copy this line and paste it and it'll work. All right. So that is where I am coming from. So when you say that it's confusing, I really want to know what is confusing. You need to point your finger and say, I don't know what this means. You know, that sort of point in that code, line number 1. I don't understand what PD is, what is read CSV is. I don't understand what read CS, what is file, what is inside file. I want that sort of question, because I'm sure it'll help a lot of us. Okay, so these are things that we need to overcome if we want to learn something new. All right. Okay, so I think I needed to do this because we have been asking for input, feedback, but we are not getting enough. Okay, and this is not for me. It's actually for you guys to come out of your shell and start asking questions. If you don't know, you don't know. If you know, you know. It's not about, oh, if I ask a question, they think I'm stupid. It's okay. So what if they think they're stupid? You know, you'd rather be stupid for a minute than be wise forever. So come out of that and ask questions. I want the session to be more engaging. That's probably the only thank you can give me, by giving me more feedback, more comments. Whether it's good or bad, I will decide, but a comment is a comment. So let's proceed. So today's class is going to focus on some form of prediction. Okay, we are slowly taking baby steps into this whole machine learning, deep learning sort of a thing. Okay, so our first exercise, which I have chosen for you, is to predict handphone prices. What handphone? iPhone. I know all of you like to have an iPhone, right? So I have taken the information from the web. I stole it from the web, from Wikipedia. I took that information and I put it into a column. All right. So the important thing about this sort of learning is preparing the data set. Preparing the data set. Let's say you wanted to buy a PS5 or something like that. All right. You wanted to know what is going to be the price, the best price. So you can go to different websites and collect the, no, that's not a good example. Let's say you wanted to predict what is going to be the price of PS6. I don't know. You can actually predict that using machine learning. Okay. So we are going to do some predictions. So we know that the past 14 phones have a particular price, or 16 phones. So let's predict what is going to be the 17th phone price, approximately. It's most probably going to be wrong, but it's very close to the correct answer. All right. So that's called a prediction. All right. So when the phone comes out, we will then measure how far away we are from the actual price. Then we make some corrections, and then that's what machine does. You know, it keeps learning. Each time it makes a mistake, it corrects itself. Makes a mistake, corrects it left. You know, there was this funny joke about this 20-year-old guy. He was asking a computer, "How old am I?" Then the computer said 3 years old. Then he said, "No, I'm 20 years old." Then he asked the computer again, "How old am I?" It said, "You're 15 years old." Then he said, "No, I'm 20 years old." And then he tries again. The computer corrects itself. And then it says, "How old am I?" "I'm 20 years old." Then the computer says, "I'm 20. Yeah, you're 20 years old." So it's not like it immediately got the answer correct. It over time, after multiple tries, then it became correct. So that is the idea of machine learning. That means it learns and learns and learns and corrects itself. And first it predicts, then it learns, it corrects itself, and then predicts, and it keeps going on until yeah, the guy was actually it's a joke, by the way. This guy is actually a data scientist, and he was showing how the machine actually learns. So you have to continuously tell it the correct price. All right. When you do that, it begins to learn what is the correct price and against what it's predicted. So it starts to change the weights and biases to get the right result. Okay, so we're going to do that. And I have the data set already listed inside the GitHub. Okay, if you open the GitHub, you will see that the data set is already sitting here. Wait a minute. Where am I? Masterclass, block main, iPhone. Okay, so the data set is there. I can't see it here. There, it's here. iPhone prices. So if you click on the iPhone prices, it goes to they have a block main CSV. So it actually shows you the files, the data. All right. So whatever experiment that you want to do, okay, whatever you want to predict, if it's, let's say, house prices, because the values are continuous, that means it's 499, then it's 599. They have 3 models that are 599. Then the 5th model is the iPhone 4S 16 gigabit, which is 649. So you have 4 phones that are 649. Then you have suddenly a iPhone 6 Plus that's a bit more expensive, and then iPhone 6X comes down. So you can see that that is not a linear growth. That means there's some funny behavior to the so it's impossible to actually predict. Then you can see suddenly iPhone X is like 1,000 US. Okay, all these prices are in US dollars. So you need to build this sort of a data set for anything that you want to predict. Okay, let's say you wanted to predict house prices or PS5 machines, or even school fees, or how school fees has been growing. Not school fees as in like university fees and stuff like that. You can actually predict the behavior, whether there is a pattern, and you need to prepare the data set by giving it the information that it needs. Okay, so what we are going to use is we are going to use the number column, and the phone name of the phone is actually useless. All right, so but it's okay, we leave it there. What is important is the number and the price, because the first one is 499, the second one is 599. So you must understand that machines don't really bother about the text, they just look at the numbers. So we need to set up a data set of numbers in correlation, and then it will start to learn the pattern of the relationship between 1 and 499, 2 and 599, and so on and so forth until we come to 16. All right. So the numbering system is that this is actually the 0th value. All right. So when we go into our data frame, all right, you can see it's got a number and it's also got a 0 in front of it. So you must understand math actually starts with 0. So 0 is actually the first number, and this is called the index. Okay, indexes are very, very important because I don't want to remember all the information. I just remember the index, I'm good to go. Okay, so in most databases and stuff like that, we use indexes, or even if we want to remember information about a system, we actually create a system of indexes. So it's like a library system. And you know, where you have these numbers indicating where the book is, which shelf, and all of the stuff. So that is actually called an indexing system inside data frame, which is the pandas data frame. So if you all remember previously, we imported our good friend pandas, okay, and pandas is called PD for our purpose of this example. And inside pandas, you have this read CSV file function or method. Okay, this method is going to read this URL, but remember to put question mark raw equals to true, because I want it to come as a raw form. If I don't put that, it is going to give me in this form, which is useless. It's got the header and all that other stuff that I don't need. So I want it to be raw. Okay, so you can actually do this multiple ways. You can actually open your tab here, sorry, this tab here. You can see you can upload a file. You can connect to your G drive. So there are many ways for you to upload the file. I just made it easy for you so you don't have to do anything. Just click on this and you will go and pick up the file from here. All right. So you're not just limited to what files I give you. Okay, you can actually do it on any particular file that you want. And this information also. Now, 85% of projects in data science fail because they don't create this table well. They don't put in the fields that are descriptive of the output, because we are going to use the number column to predict the price, right? So we need to know that these numbers are clean. That means you can see that this is an integer, this is a float value, you know, these things needs to be first. So what we do is, I'm going to do some little things. So you can actually play around. Just put df as in data frame dot info. Okay, that will print out the information inside the data frame. So we have created this data frame. And now I can see that the first one is a number of type integer 64. Okay, what is this 64? The 64 is actually telling you about the kind of processor that is running behind this web page. It's a 64-bit processor. That means it's got 64 different locations for it to store. So the more bits it's got, the larger the number can be. All right. So that's why it's called integer 64. The same for the other one, which is a float. Floating point means it's a decimal place. It can be an integer, but it's also got a decimal number to it. Again, it's been allocated 64 bits of information to be stored. So if you put more decimal places, then the actual size of the number starts to reduce. So the limitation is the processor that is running it. So if you run it on older machines, it will be INT32, let's say. And remember, when I actually started programming, it was INT8. Okay, that's how dinosaurish I am in this business. Okay. So we always have to manage with the space that we are given. And so now you have the luxury of running it on a 64-bit machine. All right. And most computers today are 64-bit anyway. So now you understand why the type in lesson 1 and 2, I was stressing on what is an integer, what is a float, and you can see name, it says an object. Basically, it's saying, I don't know what it is. An object can mean anything, all right? But the thing is, a string is considered as an object because it's a combination of characters and arrays, okay? So that's why it's saying that I don't really know what this is, so I'm going to call it as an object. It's saying that, hey, be careful when you handle this because it is not straightforward, okay? So that is where we are coming from, all right? Then you can do, so these are little things that we can apply onto the data set before we begin our experiment. So that's another one that I want to show you called describe. I think we did this already, but now you can see why we have this these functions. So it's telling us that there is an equal number of values for the column number and the column price. So we can see that our data set is very, very good because it's equal number, because we cannot have situations where it's empty or it's null, all right? This will cause a problem. So we have a mean value. In this case, it doesn't really mean much, but this is just some additional information looking at the mean, the standard deviation, and so on and so forth, right? So we have a good data set. Now, we are going to start with linear model. Linear model means that it's a straight line, okay? So I'm going to show you some linear models. Okay, so these are linear regressions, okay? It's not too complicated. I have a bunch of points, okay? And these points actually don't make any much sense, but I'm going to start trying to find the best line to fit all these values. This is called linear regression, okay? Linear regression is trying to predict what is the approximate value given a particular input. So you can see this one, this graph is called my grumpiness from 0 to 100 and how many hours I slept. So it's obvious that the more I sleep, the less grumpier I am. All right. So this is what we can infer from the information of the graph. And this is what linear regression tells us. That means, is there a downward slope or an upward slope, or there is no slope? Okay. So now we're going to talk about iPhone prices and to see whether there is a downward slope or an upward slope. Okay. I know you already know that it's an upward slope, but how much are we going to change for each new phone? All right. So let's try to run the code. Okay. The first thing is we create a model. That means we are doing a linear regression model. And there are many models that you can do. You have linear regression, polynomial regression, because regression is, linear regression is the most basic. Okay. So I don't want to confuse you. Let's just do linear regression. Linear means straight. Okay. Regression means taking the past and projecting it to the future. So that is a regression. Okay. So we're going to do that in a straight line. So all you need to do is run this. Okay. And every model, okay, not just the linear regression model. Later we will be doing machine learning models. Okay. There are a few techniques that we can do in machine learning. For example, I don't want to scare you, but it's a mathematics that was developed almost 65 years ago. Okay, it's not very current. You know, what's current is maybe about 10-15 years ago. But I'm talking about classification methods of that was built 60 years ago. So we will talk about that in the next coming classes. All right. So linear regression is very, very useful for continuous values. That means you can see that the price is actually increasing over time. First, it starts off at 400, then it's 600, 650, 750, and then 1,000. So there is a gradient. That means there is a slight increase for each percentage. So we know that this is going to be increment. But now we want to know increment by how much. Okay. So in order to do this, okay, we just have to run one function here. Okay. For those of you who don't understand this, put up your hand and say, I don't understand. But first, let me explain. After I explain, you still don't understand, ask again. It's okay. It's no problem. I'm not going to judge you. Okay. Nobody's going to judge you. So when we create a model, we have to use the word fit. Fit is when it's going to train. It's going to, you know what I told you just now, it's like a machine. It's going to try and then fail and then correct itself and then try again and then it's going to fail and then it's going to correct itself and it's going to correct itself until it finds the best solution. The best solution means the lowest amount of error. Okay, so so we've done the fit. All right, so it's got it's printed out what is that? No, I haven't run it yet. So it's got it's already built. This is the output. Okay, now we want to do some prediction. Okay, so you can see that my values end at 16. So I have to give it an input. Okay, so what did I give it to? Sorry, before I go there, let's see what this means here. This is actually pointing to the data frame and the entire column of number as the X input or the input, and the predicted. What I want to predict is the price. So it's as that simple. You just put in X and the labels and the predicted value. It will do the math for you. You don't have to understand anything beyond this. It's like when you drive a car, you know. You start the engine. Do you need to know what is actually happening, the alternator, the battery, and all of that stuff? No need, right? All you know, the car started. Yes. So we can move on to the next step. So once you just need to give it the values that you want it to predict on. So that means you're giving it the number column and the price column. So this text here is actually coinciding with the name of the column. See, this is number, this is price. Be sure to make sure the case is the same because it's very case sensitive. If you make the case insensitive, then it won't know that you're talking about that column. Okay, so when you run this and you get this output, that means it's very happy. It knows what you're asking for. So now, once we have trained the model, so what happens is the model will learn the parameters and save it inside the model value. And now what we do is we have to run the prediction. So voila. So it has predicted that the 17th phone price is 851,299. So this one we can actually format this. How do we do that? Is to format. If we want it to be a bit more, we want it to be like 2 decimal place. So what we do is 2F, put in the colon. So this is formatting it. and I want it to be 2 decimal places. You see, even I am like trial and error, all right? Because I don't remember all this garbage, because one language will have F and another language will have colon, and you can't be, limited by all of this. You just try. If it fails, you try something else, it just moves on. So now it looks better. It looks like actually it's a what is that, actual currency value, all right? So it has actually predicted the value for you. And how did it do this? Okay, how did it do this? So now let's plot let me just remove this. So now I'm going to plot. Okay, plotting is also same. I just put in the X value. Okay, but you see now, when I put in the X value here, I'm not putting the double quotes. These are little things that you need to remember. Okay, so in when you train it as a model, you need to give it as a double. It must be basically, when you do this, it's got an index and then the number, and then this one also has got an index and then the price. So that's why they match. So in data frame, in pandas, you just have to do this double brackets and it will create that. So this is something you need to remember when you do model fitting and model training, because every value must need an index. But in this case, it's just giving the number column and giving the price column, similar to X and Y. Okay, all you need to do is play this and it will plot. You can see that the prices are not actually linear. That means there is no straight line that is going to solve this. So the answer of 851 is definitely wrong, but very close to the actual value. All right. So if I have the 17th phone, I probably will be maybe $50 or more or $50 less. Doesn't matter. But the idea is, I know roughly now it's going to be about 850. It can be 900, but definitely not too much less than 850. So I have a band of values that I can start projecting. So if I wanted to save money for buying the most latest iPhone, I know roughly I need about $850 to buy this phone, which is about 3,200 or 3,400 ringgit. All right. So I'm not asking you to buy, but I'm just telling you how to predict the price of a phone that is not yet released, okay, or not yet found in the data set. Okay, so this is how we actually do linear regression and to predict. Okay, so I am going to stop here. I'm going to take a 15-minute break. Okay, and I will just step away for a while and come back. But if you have any questions, you can post it in the chat group. If there's anything else you want me to repeat, or if there's anything more advanced you want to talk about, and for those who have ideas of doing something with other data sets, I can also help you, give you some suggestions. Okay, so I'm going to take a 15-minute break and I will come back at 11. So when we talk about, I'm just answering your question, Nirmala. So even in this example here, we are actually doing the model fit is called the training. Okay, so this part is where we are supplying the 16 values. Okay, so usually what we do is we split this to two parts. One, maybe we take the first 10 as training, and then we take the next 7 as testing. So we have two sets of data, but it's from the same data set. Okay, so what we so there is we will do this in machine learning, where we will create two data sets, one for training and one for testing. So once you create a model, you can actually test it with previous data that it's not seen before. For example, let's say if we build a model for all transactions in Malaysia, let's say, but then suddenly you want to test it on transactions running in Singapore within the same time period. So you actually trying to see whether your model works for Malaysia and Singapore. It's just an example. So you can also go backwards. That means you're doing a model for, let's say, 2021, but then you want to test whether it can work for 2020 or 2019, because your data repository has got all this data already. So you can actually test your model by going backwards. But realistically, it's the data scientist's call whether that information is valuable for the future or not, because they have to see correlations to see whether the information gained from the current data set is going, I mean, the back testing is going to add value to the future, right? So these are just techniques that the data scientists use, and usually for different industries, they have different techniques. Like the airline industry cannot do back testing at all. For example, the restaurant industry cannot do back testing at all. But the banking sector can do back testing. So it depends on industry. It depends on how valuable the data is. So we actually did our testing on the first 16 records. And we're doing the prediction on the 17th record. So you can see that I'm passing in the matrix of 17, and this is the input, and then it generates the prediction. So this is a very, very simple, very rudimentary example of that. So it can get more complex. So you are at a very complex environment. We are at a very simple level. So this is how it begins. And then now we can break it down further. So you can see that when I did the testing, this predict is actually to test. So I am doing the training here, and I'm doing the testing here, in other words. So when I test it, I'm giving it a value that is not seen before. So what is the meaning of testing is that giving it a value that is never seen before and seeing how it's going to behave. So it's not seen 17, but I'm giving it 17 to see how it's responding. So this is what, this process here is actually quite an involved part. Although it's 2 lines of code, but it can be broken up into various types of verticals for different industry. I hope it makes sense. Okay, so now I understand that you are actually looking to understand the confusion matrix. Okay, so let me see if I can explain. Do I explain the confusion matrix here? Yeah. Okay. Okay, so let's continue on. So now we need to know that how good our model is, all right? Because just because we can predict, that doesn't mean it's useful, right? So now is when the probability and the statistics and all of that kicks in, okay? So, so this is the price column, okay? And then now I've just, for the fun of it, I've just created a new column called currency, and assuming that Malaysian ringgit is 4.2 times the US dollar, so we can easily create a new column called currency and convert the US dollar to currency, and we have it in our local currency, right? So here, what I have done is I am calling the predict again, and I'm giving it all the values that that it initially that means the numbers from 1 to 16. So it's going to use the same model and predict again. So the previous value was 499, but it's predicting 537. So you can see these are all predicted values. And finally, for the 16th, it's predicted it as 831, but when the value was actually 999. So you can see that the values are not correct at all. Okay, they probably 1, maybe 2 is actually correct. Now, how do we handle this? So when you plot the line that we drew, okay, the predicted, this is what we have predicted. Okay, so you can see the predicted value is actually calculated using this, and then the number, and then we have a plot line, which is red color, and then we have the scatter line. So you can see this is the actual values, the blue values, but the regression model has predicted this as the best fit. Now, how do we measure that this is the best fit? Because you can see, let me just open up another slide of mine. This is from another class. So when we actually have a model, right, it begins with a random value, right? Then it starts to, you can see that there is a kind of a inclination of how, can I play this? Supposed to play. It doesn't have a play button. Yeah. So to explain how we actually evaluate a regression model, okay? How do we evaluate this is, you can see that these are the scatter points and this is the predicted line, okay? And the predicted line, in our case, it's a bit better because it's hit this point. It's very close to this point. It's almost very close, but certain points have pulled it away. That means this value is completely out of this world, and this one is just out of the graph. So we can actually see that our model has got an error, okay? And we want to know how bad is this error. And how we calculate is we look at the distance between the predicted value and the actual value. And we do it for all of it. All right. So we do for all the lines and then we sum all the error together. Okay. So when we get a very large value for this, then we know the line is not the best. Okay. So this is called mean squared error. That means I am taking the error mean because I am minusing the mean value against the predicted. This is the mean value of the entire data set. So that's why when we have the, and then we take the square, basically it's the Pythagoras theorem. We take the square because we do not care of the negative sign or the positive sign. We don't care whether it's above or bottom. And then we take the square root of this. So that's why it's mean square error. And we divide it by the number of samples. And then we will get a value. This value is called the evaluation method for regression. So if you have every model, whether it's a regression or classification, has got what is known as a evaluation method. If without an evaluation method, it's absolutely useless. All right. So how we measure how good our prediction is by looking at the regression mean squared error. Okay, for regression, there's mean squared error, and then there's also a few others. You have this is mean squared error. This is root mean squared. That means they just take the square root of the value, and then they have absolute error. All this is to make sure that we look at how intense, how far away we are from the actual truth. because this is the truth, ground truth, okay? And this is our predicted. So when we sum all of this together, we will get a value that tells us how good our prediction is. So this is the fundamental understanding of machine learning, where we begin by evaluating how good our prediction is by looking at the evaluation matrix. So whenever you have a regression problem, regression means continuous value. That means like house prices, stock prices, phone prices, anything that has got to do with price or time is called continuous. Okay. So when you want to solve a continuous value problem, we have to use a regression method, and every method has got an evaluation method. And for regression, specifically for regression, we have mean squared error, root mean squared error, and mean absolute error. Okay. That is why this class is really fun for those who love mathematics. So I hope you understand. So you can actually print out the errors. Okay. Let me just check how. So we have, before we go in here, I'm just going to create another code line and see. So we can do certain things. We have the model, right? So you can type model and it will show you, you can find the coefficient. You can print the coefficient. The coefficient is actually the gradient of, because it's actually, the line is actually y equals to mx plus c, the straight line. So m is actually the coefficient. Okay. And then, so these are things that we can print out. You can actually see from the, so if you wanted to draw this line, if you wanted to draw this line, this is the coefficient, this is the gradient, 19 something. Then you have the intercept. You have, you can put model dot intercept, right? Again, that will tell you where is it going to intercept so it's going to intercept the y-axis at 518. All right. So we can actually find out all these things about the model. Okay. So there is another thing that we can do. Okay. If you wanted to look for again from sklearn, all right. We wanted to import matrix. Okay, so this one allows me to predict you can see the error. Okay, so I'm going to copy and paste the errors in here, but with some changes. So this is to look at. So with one particular function, we can actually predict. So we can actually put in the value, which is df. What is that? the y value, which is price, and then here we can put the predicted value. So we are going to compare the actual values of price against predict, and this same thing is copied and pasted here all over this place. So you can see that now we are going to test your model. So if somebody comes up and says, hey, I built a model to predict handphone prices, this is how you actually test it. I have to, what did I do wrong? Predict is not defined. Let me just check. Currency, did I run predict? Oh, predict is here. So I need to do it down here. So I need to run predict first. This has not been run. So after I run predict, then I can run this. Okay, what is missing is NP. So I need to, no, I have to import NumPy. NumPy is another library, which is what the fundamentals of pandas. So, so you can see that the mean square error value, the squared error value, and the root mean square error. These are three different ways of measuring the validity of this this prediction. So we have predicted the value. Now we can actually put it inside these functions, and it will tell us whether the validation is good. So this is the first run. This is the first run. Okay. So now I can repeat this process, right, by removing certain values. That means I'm going to improve my prediction. If I, let's say, if I took away this value, I could improve my prediction. So how I can improve my prediction is by removing column number 16. That's one way of doing it. All right. So what I can do is I can what is that? So this is what machine learning is. So this is the current prediction for all 16 points. Okay. So if I wanted to improve my prediction, what I do is I do some we call it regularization, right? But regularization means that I'm taking off points that are out of the normal. So it's an abnormal behavior. So by eliminating abnormality, I can make it more predictable. So I can continue to do this, and this is what back testing can be, where I'm going back and correcting my data set and then testing it again. So my benchmark will be the next set of values against this values here. I hope it makes sense. Okay, so this is how we actually do linear regression, and this is how we evaluate the linear regression. So since we have time, I will go ahead and do this. Okay, I'm going to print it out. Okay, it's we've already done this. So now I'm going to do my code, and I'm going to create another data set, df2, but here this is going to be df. Remember, I showed you how to start and end. So I want to go all the way from the beginning, and I want to go inside one. That means I want to remove the 16th character, 16th value. So I can then I can do df2.head. That means I want to see, no, I want to do tail. I want to see the bottom end of this data set. So it's so easy for me to manipulate. So you can see I've removed column 16. Okay, because column 16 is a very odd number. So I can, to show you what I have done, I can just print this. I can add another line of code here. And instead of df, I put df2. All right. Okay, I have to remove this because I have to do prediction again. So this one I'm going to put df2 and price 2 because it's a new data set, plot show. So you can see now that it stops here. So there is a bit more, less abnormality, okay? Because it's a bit more predictable. Okay, let's bring it even now. Let's do the model fitting again. So you see how easy it is to just go up here. Where did we do the modeling? We did the modeling here. All right. So we do the same thing, model regression, but this time we don't want to affect the changes that we've done before. So what we will do is we will put model 2. Again, it's another model, new model. In model 2, what are we going to do? We are going to do fit. Okay, and this time we're going to fit df2 and we're going to put in number, and then we are going to put in the df2 the price, right? Because it's the same price values. And then we want to create predict 2, which is model 2.predict. Okay, and then what do we want to give it? We want to give it df2. Again, we want to give it the number. All right, so we have predict and model. Then what we can do is we can just copy this code here. All right, because we've already imported these things, we don't have to do it again. We can then paste it here, but now we're going to pass in df2. All right, same thing, df2 all the way, because it's a new data set, and we're going to put predict 2. Okay, so we are going to run this, and you can see now it's got a new set of values. So if I were to compare, so let's say we want to compare the values, I can also do this, run again. So you can see now my error has reduced considerably. This is what machine learning is all about. This is what backtesting is all about. So, of course, when I just did the first round of testing, it didn't make any sense. What is 43? I don't know. What is 3008? I don't know. But then you see, when I massage the data set, okay, and I take out abnormal values, the predictions get better. The error rate gets better. So the smaller the error rate, the closer the line. Okay, so we can actually plot this. So all you have to do is go back to this one here, okay, and copy this. And I will create another code line here. And this time I will put df2, predict 2, df price 2, and df2, okay, and show. So you can see that the line is much better in approximating these things. So you can see if I can go further. I can even remove the first one because it's off the chart. Okay. So again, so we can keep doing this, but this is going to lead to another problem. It's going to overfit. That means it's going to be overfitting to the entire data set that you've given. So you'll probably hear this a lot: overfitting, underfitting, and all of that. So this is a disease. You know, overfitting and underfitting is a disease. Like, you know, when you go to the doctor, you got fever. Fever is a reaction to, that means there's something wrong in your body. So overfitting is a symptom that saying that there's something wrong with your data set. Okay. So I don't want to confuse you guys, but this is how we actually do predictions and how we improve on our predictions, all right, by massaging the data set and stuff like that. So what I had done is I removed it. Okay, not always the best idea to remove data. Okay, there are other methods that we can use. We can use regularization. Regularization is a technique where the ones that are abnormal, I give it a lesser importance. It's still there. I didn't delete it, but it's just that I don't allow it to influence my data set so much. So these are things that we will be going into when we do machine learning. All right. So you can see how easy peasy it is to do machine learning, to do predictions, to do estimation, to draw linear regression on data sets. You don't even have to be a mathematician. As long as you know what is happening, as long as you know how to evaluate, it will start to slowly make sense. So what I'm going to do, before you even ask me, I'm going to save this. Okay, and then I'm going to publish this to GitHub. Okay, and it's creating a copy. All right. So if you wanted to, you just need to go back to the GitHub and download this all over again. I will try to create in the settings. I will make it such that it doesn't capture the test. So I want you to run the test by yourself. Okay. So I will file save, loading. Okay. File save to GitHub. That's why it's important for you to be sitting in front of the computer and doing this while I am doing it. So therefore, you also will get a better picture of what is actually happening. So you can see just by looking at the regression values, we are able to now, maybe I should edit this a little bit more, but yeah. So this is just a basic introduction to regression. Not all problems can be solved with regression. Regression only handles one type of problem, okay, which is continuous values like house prices, stock prices, and so on and so forth. When we go into machine learning, there are other things that we want to predict. That means whether it is a dog or a cat, or is it a monkey or a elephant, or is it male or female? So that requires different sets of mathematics and different evaluation, but evaluation, no doubt. Okay, there must be an evaluation method to show that there is some improvement or there is some failure or disimprovement. Okay, so we will go through this step by step.